Good morning, everyone, and welcome to our EMEA Open Demos. And this morning we will be covering OpenShift on Azure, or as we better know it, ARO, which stands for Azure Red Hat OpenShift. And I would like to welcome James Reed, who will be presenting and demonstrating to us. James is a EMEA Solutions Architect, and for the past 3 to 4 years, he's been working primarily on the Red Hat products on the Azure platform. So with all of that, over to you, James, and thanks so much for giving us the hour and presenting to us.
John, thank you very much for the introduction, and thank you everybody for taking the time out of your day to come and listen to us today. So as I already said, we're going to talk about OpenShift on Azure, and probably focus on talking about Azure Red Hat OpenShift, which is the first-party cloud service. So I wear two hats at Red Hat, is the way I like to say it. So I've got a business hat and I've got a technical hat. And I certainly came into this role, came into my job with a technical hat, knowing a lot about coding and developing and that kind of stuff. And given that today we've got a live demo, I want to reassure you that we've got lots of live things in the background. We've got Azure portals, we've got OpenShift consoles, and that's what I want to show you mostly today. Okay, so it's mostly going to be a live demo day. With that being said, though, I'm going to put my business hat on for just a moment, just run through a couple of slides just to get us warmed up and to set the context. What I like to say is that I speak to a lot of technical people, day in, day out as well, and sometimes we can lose focus on, on playing around with technology and messing around with Kubernetes and learning about all these fun technologies, and lose sight of, what is the business objective? Why are we doing all this stuff? To start off with, right? I like to say that occasionally I get the chance to speak to line of business and CIOs and CTOs, and for sure, no one of those people, one of the senior leaders, have ever said, hey, that's a really cool Kubernetes platform. What they really want to see is, how does this help my business? Okay. So that being said, I'll do a couple of slides just to get us started, and then rest assured, we'll jump into some demos. So with that being said, so our agenda today, I've already said, we're going to cover OpenShift on Azure and Azure Red Hat OpenShift. So we'll spend time talking about the architecture, storage, networking, how does the support system work, and all that kind of stuff as well. But let's lead in and talk about why Red Hat OpenShift. Okay. What I'll do is actually, just because I'm going to do a few slides, I'll just go full screen. So why would you do Azure Red Hat OpenShift, or OpenShift in general, versus just doing Kubernetes? So there's a lot of services out there like EKS and AKS and GKE. A lot of customers are looking at these, evaluating them, and saying, well, why would I not just use standalone Kubernetes? Why do I need OpenShift, which essentially is an application platform? It comes down to these three things: cost, risk, and revenue. A lot of customers don't see that when they actually go to deploy OpenShift, AKS or GKE or any of the standalone Kubernetes platforms, spend a lot of time building on top of those platforms to do things like logging, monitoring, to add in service mesh support, to add in all the things they need to do in order to run enterprise applications, platforms. A lot of the time, those services can start off very low cost to provision them. It takes a very, very long time in terms of people's effort, time and resources to actually get those up to speed and to get them suitable so the security team will sign off and they can pass audit controls and that sort of thing as well. So there's a lot of cost to standalone Kubernetes. At the same time, all the time that you're spent building monitoring and logging solutions on top of standalone Kubernetes represents a huge risk to the business. A lot of business decision makers care about, has this thing been tested? Is it supported? Are there any certifications for this? Not just on the technical side, but if I'm running a bank, well, has this thing passed SOC 2 Type 2? Can I run PCI DSS applications on top of it? And those sort of things as well. Ultimately, business decision makers care about how it's going to affect their revenue. So is this going to allow me to deliver applications faster? Is this going to allow my developers to be more productive? And answer those sort of questions as well. So those are things that I think decision makers care about a lot of the time. I think as a technical community, we need to bear in mind when we're learning about the technology. Again, I've only got a couple of slides, so bear with me, but I just wanted to kind of tell a bit of a story, right? We find as Red Hat, and I think if you look out in the community now, talking to any customer, all customers have got the objective of getting applications into the cloud. Mostly into the public cloud, sometimes in the private cloud, and a lot of those applications today are very much designed and run and built on premises, or maybe built with kind of traditional development techniques rather than using DevOps and CI/CD. And a lot of customers say, well, we want to get our applications to the cloud. We want to see cost efficiencies. We want to be developing in a cloud native way. We want to be having our applications pushing our business forward, giving us competitive advantages and not holding us back and with huge costs in running these applications. A lot of businesses can also work out that in order to get to the clouds, there's a very compelling technology out there today, Kubernetes, and if we can just conquer this technology, just climb this mountain and get over this, then we'll be a lot closer towards running our applications in the cloud, and we'll be deploying and running everything in a cloud native way. The problem with that is that Kubernetes is complex, and Kubernetes is just really the start of that mountain. Remember I said before that a lot of customers will start off with Kubernetes and start off with the container orchestration, but very quickly realize they need container logging and monitoring. They've got to spend time messing around with Helm charts. They've got to spend time building security controls into the system, and so it becomes quite complex. As IT professionals, as people who are interested in technology, we're all loving learning about technology and learning about Kubernetes. We're getting lots of new skills, but sometimes a lot of these IT professionals who are learning these skills are not really helping the business move applications forward and getting them migrated towards the cloud. So again, we've got to consider how we meet the business objectives as technologists, enable those business outcomes that our line of business are looking for. This is my last slide, so by all means we're going to get into the technology at the moment, but I want to show you what a typical journey, a typical engagement looks like between Red Hat and most of our customers as they're looking towards OpenShift. Most customers start off on the left-hand side of the slide. They start off by saying, hey, we can get containers running on a laptop. Probably did this a few years ago, really, at this stage. Maybe played around with Docker Desktop and said, hey, this container thing is really cool. I can get a MongoDB database up and running, or I can get my .NET app into a container. This could have real benefits for us. A little bit later on in that journey, the customers will start to realize that you start wanting to run multi-container applications. So I want my application in a database in a container and my database in a container. Sometimes those applications can make up more and more containers, and eventually most customers get to a point saying, well, we need more servers. And when you've got more servers and lots of applications running in containers, you very quickly realize you need container orchestration. And most customers can work that out on their own. Most customers can work out that, okay, Kubernetes is the technology we need. Let's start playing around with Kubernetes. That's when the hill starts to really get a lot steeper and the climb starts to get a little more difficult. A lot of customers can get the applications running in the container and the containers running on Kubernetes. But then you've got to work out problems like CI/CD. Now there's a lot of options out there in the market for CI/CD today. Tekton, Azure DevOps, Jenkins X, lots and lots of options. And any one of those options takes a long time often to set up, to configure, to get working nicely with your container solution. And it's not just about deploying the container, it's about how do you get an entire release pipeline working with containers, right? It's about how do we do roll forwards, roll backwards, A/B deployments, and all that kind of stuff as well. We often will engage with customers when they're at this point and they've spent weeks and months of effort getting things like Azure, getting things like CI/CD working with their platform. Next up can be monitoring. Okay, so you think this is quite simple. I go grab my favorite Helm chart for Grafana and Prometheus, or Datadog, or whatever technology you want to use. Then you start to find that actually running this at scale inside containers can become quite tricky. So a lot of customers engage at this point. They're saying, we love Kubernetes, we get it, the technology is great, but we're starting to ask the question, do we want an empty Kubernetes environment, or do we need something like OpenShift, which is your application platform? Now, Red Hat's got a lot of experience in working with containers and working with Kubernetes. And a lot of times I'll say to customers that you're trying to tackle some of these technical challenges today, like CI/CD and monitoring. What you don't realize is there's a lot of challenges around the corner if you continue on the path of going on empty Kubernetes environments. Because then you've got to start solve some of the problems that are coming up, like enterprise authentication, hybrid connectivity, and audit controls. You've then got to solve problems around security, such as software supply chain or connectivity between services. Do we use open source? How does security work with the OS? And so on, things like that. Now, I'm not going to read out all the points on the slide, but you can start to realize there's a lot of day two concerns and day two challenges when it comes to running Kubernetes. And each one of these can be technically overcome within your organization. You can spend time building Helm charts and deploying container images from Docker Hub and all that kind of stuff. And you can build your own application platform, I suppose. But what you won't have is a platform that's tested, that's integrated, a platform that's certified, or a platform that's supported. And when we come back to think about our business objectives, what does that mean for the business? It means as a technical person, you have kind of exposed the business to unnecessary cost, risk, and you're not helping the business meet its revenue objectives. Now, that being said, that was my last slide, but I want you to keep that in mind. What I want to show you now in the demo as we get into it is how OpenShift is a tightly engineered platform, application platform, with all those bits and pieces working well together, all supported and certified by Red Hat. Now, today we're going to focus on Azure Red Hat OpenShift. Okay? So what I have here is a deployed OpenShift environment. Now, hopefully, many of you on the call have already seen OpenShift live, working in many other sessions. So what I will do is I'll focus a bit more on the Azure side of things. So how did I get here? Well, I started off my Azure console. So I think it was last night. Yeah, it was last night. I deployed this demo environment and got this up and running. It's extremely simple. It's forward. You can see that it's a first-party native service in the Azure console. You can see there's resource groups, there's subscriptions, there's marketplace. But Azure Red Hat OpenShift is a first-party native service delivered by Microsoft and Red Hat. I just want you to think about that for a second. Microsoft came to Red Hat and said, we need Azure Red Hat OpenShift running in our environment, running on Azure. We recognize that many customers are running OpenShift already on premises. And while we have AKS and lots of customers are doing their own Kubernetes deployments and offerings, we want to partner with Red Hat and make Azure Red Hat OpenShift a reality for customers. So in 2019, this was the first cloud service that Red Hat launched with Microsoft. It was unique at the time. And again, we were launched on OpenShift version 3, which is now, unfortunately, ancient history. But today, we're running OpenShift version 4, ARO version 4, with the latest versions available inside. So you as an administrator can come to your Azure console and deploy Azure Red Hat OpenShift. The actual deployment can be done via command line. It can be done graphically as well. So if we go to the portal here, we can create a cluster and get this up and running. And I'm not going to do this now because otherwise we'll be sitting here waiting for the installation to complete. And it takes about 30 to 40 minutes, and you don't want to take all of your time. But you can see it's very straightforward. Choose the region, choose the master size, choose the worker size, scale those as many as you need. Then you go ahead with the next few steps, the wizard, and create an ARO cluster. So while the command line is available, you can do everything via the console, and that's pretty normal the first time you do it, get everything up and running. A lot of customers after that will go ahead and script it. A lot of customers will use Ansible templates or even use ARM templates to provision it. But fundamentally, all you're doing is giving it a cluster name, you're giving it a virtual network, some subnets, and then OpenShift installer just kind of runs itself. You don't have to worry about any of the underlying details when it comes to the actual installation. So the installation is kind of boring, and that's by design. We don't want the installation to be complex. We don't want the installation to ever fail. So we've put a lot of engineering effort into making sure that provisioning process is simple and straightforward. At the end of the provisioning process, you'll see I have an ARO cluster, an OpenShift cluster, running in my Azure subscription. Okay. So this is deployed into your Azure subscription. You can see all of the resources deployed behind it, but fundamentally they're hidden from you by default, because you don't need to worry about any of the details that are running behind it. It's all read-only from your perspective. And what you get is a fully supported application platform for running containers that is suitable and ready for production from day one. Well, from 40 minutes, right? That's what it takes to deploy a cluster. You can see in this case that I deployed a public cluster. Now, in most cases, you will deploy it privately, so that's only accessible from inside Azure or over your express route connection. But I'm running OpenShift 4.10. Okay, so pretty much what the latest, well, it is the latest minor version, and there's a couple of patches. We'll talk about that and how patching works in just a second. So that's what it looks like from the Azure side of things. Very straightforward, but again, deployed into your Azure subscription. And again, that's got a huge benefit, as it means that the deployment will follow your Azure Active Directory, follow your Azure policy controls, integrate into your express route, and that has a huge benefit of making OpenShift feel like a first-class citizen within your Azure environment. So going back to the console then, so I've logged in, as you can see, with an administrative user as kubeadmin. Okay, just makes my demos very easy, as I'm a full admin, full root user. But just talking from your perspective as a customer, you have full admin over the cluster. Okay, so while on the Azure side, we make a lot of things read-only, so you can't play with the machines, you can't change the underlying architecture of the service, and we've designed it that way so that you can't. Well, we try to reduce the amount of ways to break the service, if that makes sense, right? What you really want is an application platform that's running 24/7, 365, with a support team behind it, if anything goes wrong. But really, from the Azure side of things, this is following our reference architecture. Within OpenShift, as I said, you do have full admin capabilities, which means you can deploy anything you like. You can deploy any operator, you can deploy any daemon set. You could even log into the nodes and get to their console if you need to. But realistically, you shouldn't need to do any of that, as much of the day-to-day admin and let's say healthcare, I guess, of the service is done by the SRE team that's backing this cluster. So there's a site reliability team behind the scenes, making sure that everything is healthy and everything is working properly. You see I've got a few failed pods and a few warnings. That's totally normal. I've got a few things deployed or halfway through deployments there. So don't worry about that. What we care about is the cluster is green, the control panel is green, the operators are green. Okay. So let's go into this in a little bit more detail. If we go to our cluster settings, again, you'll see from the OpenShift console, I'll just zoom in one level. The OpenShift console is 4.10.15. Okay, so we're running the latest minor version, which is 4.10 of OpenShift. We were a few patches behind though. So with 4.10.15 versus 4.10.18 that is actually available. And that's kind of by design. What we take care of in the managed service is that we take care of all the security patches for you. Okay? And we'll also obviously take care of stability of the platform and health of the platform as well. But let's say between 4.10.15 and 4.10.18, it looks like we've not had any security updates required of the platform. Our mission and our objective from the support side of things is to keep everything stable, to keep everything running so that we run OpenShift and you run your applications. So if there's no reason to patch this from a security perspective, we leave it up to you as a customer to choose when to apply those optional patches. So we can say between 4.10.15 and 4.10.18, there's been no security patches, but there probably has been a few additional features. There may even be a few bug fixes, but then you get to choose to apply those and update them when you choose. Right? You probably do this during a normal patching schedule or patching time during the week. But otherwise, again, we'll look after security patches and the rest is over to you. Let's go to the cluster operators. Now, for those of you that have seen OpenShift before, this will probably be something you're already aware of. But just to cover some of this for maybe folks that are new to this or want to know how this works, the SRE team, the support team behind the service, their responsibility is to make sure all these cluster operators are always green and available. Okay, so we will take care that authentication is working. Your cloud credentials, your the cluster autoscaler, the console. We check that those are all available and always working. Now this is a big deal, and this is also starting to look at some of the things that are running in OpenShift as an application platform versus XKS or AKS as just a standalone Kubernetes environment. If you were building your own application platform or building on top of AKS or GKE or any of those standalone Kubernetes offerings, eventually you're probably going to get to a point where you need to care and worry about all these components. So, while you don't have one by default, an image registry or a container registry, eventually you're going to have to deploy one. You'll find as you get further on into production, we're going to need our own container registry. Or we need to kind of look after etcd, the database, running behind the service. Some other things you need to look at the network or even node tuning. And again, a technologist or a sysadmin can look after all those things, but again, very quickly, that is not delivering direct value to the business. It's not your core responsibility. And that's a big difference compared to ARO as a managed service, where we look after all these components for you. So huge time saving by knowing that all those components, they're all critical to running a Kubernetes application platform, but we are looking after that for you as a customer, and we're supporting you as well. If we do ever have an issue, if you have a customer got a problem with any of those operators or problem with anything running in the OpenShift environment, you can of course raise a support ticket. So if we go down here, go back to our Azure console, click on my Azure, my ARO instance, and this is how I raise a support request. Those of you, of course, familiar with Azure will know how this works. You can go ahead here and raise a support request and make sure that you raise an issue if something is not working or you're maybe not seeing the right performance or something like that. And that will go to an integrated support team. That goes to Red Hat and to Microsoft. Okay, it goes to a single team that's staffed by Red Hatters and Microsoft people. And if it's picked up by a Microsoft person, and the Microsoft person says, "Oh, this looks like it's maybe more of an OpenShift operator issue," or it looks like it's a problem with pipelines or something like that, then it means that the Microsoft person will ask one of their Red Hat colleagues to look at that issue and resolve that for you. On the other hand, if it's more of an Azure issue, if maybe a region is failing or a VM is crashing, of course, we'll ask internally for a Microsoft person to look at that support issue. From your perspective as a customer, as someone consuming Azure Red Hat OpenShift, what you get is a single service where you only have to raise a single ticket and you get support on everything from the power in the data center up to the physical machine, the network, the storage. You get support on the availability zones, you get support on the operating system, on Linux, on the containers, on all the disks. You get support on OpenShift, on CoreOS, and all the operators, all from one single support team. But remember as well, it's not just a Kubernetes infrastructure. So we'll support you on DNS. We all know it's always DNS causing the problem, right? It's always that issue. But we'll support you on the container registry, we'll support with etcd, ingress controls, and all this kind of stuff. Again, if you do this alone, that's a huge burden on you as a support team if you're building it on top of your own standalone Kubernetes environment. So one support channel for everything from powering the data center up to the health of the cluster operators and everything in between. So that's a big game changer with a managed service. So that's the operators, that's the cluster operators. I want to show you now the application operators, okay? Or just call them operators. Right? So for those of you maybe not so familiar with operators, if maybe you're more familiar with Helm charts, or even downloading YAML files from the internet and applying those to your cluster, that's not the Red Hat way. We avoid Helm charts, certainly compatible with them if you want to use them, by all means. And we certainly don't download YAML files off the internet and just apply them to the cluster, right? Within OpenShift, everything is deployed by Red Hat and by our partners as an operator, okay? And that is, again, a huge game changer. An operator takes care of the full life cycle of an application. Okay? So what that means is it takes care of deployments, and often it will take care of patching that application, scaling it, rolling out updates, looking after the health of the application. And so for each one of these technologies here, we've got over 375 items or so in the catalog now. Each of these operators will look after various workloads running on OpenShift. Now, the big deal here is that we've got many Red Hat operators to extend the functionality of the platform that's included with the OpenShift subscription cost. So for those of you more familiar with OpenShift, and if you've got a few OpenShift clusters already, you maybe have heard of Red Hat Advanced Cluster Management for Kubernetes, or ACM for short. That is fully supported on top of ARO, both as a management cluster and as a hub cluster as well. So what this allows you to do is to be able to manage multiple clusters, and I've got customers today who manage clusters on premises and clusters running in Azure using advanced cluster management. Also, advanced cluster security, again, is also available on top of Azure Red Hat OpenShift. So again, this is providing things like image scanning, this is providing things like in-depth analytics into your container images, looking at what's actually included. Are there any vulnerabilities? Are there any issues with that container image? Are there any operational issues at runtime in terms of how that container image is being deployed? And there's lots of ways in there to apply controls for security standards. And sorry, I misspoke a little bit earlier. These are additional extras on top of OpenShift, so they're fully supported, but that requires a separate Red Hat subscription. What doesn't require a separate subscription, and what is included, are many of the things listed here. So if we just look at some of them, so you've got the option to use maybe local storage or OpenShift Advanced Data Protection. There's also Elasticsearch in here. There's code-ready workspaces, which is a way for deploying like an IDE, like a development environment. That's a bit like Visual Studio Code, I suppose, inside OpenShift. There are operators in here for service mesh, serverless, and many other options like that as well. So many of these are included with the OpenShift subscription. One of my favorite ones, if you've not seen it before, I know a lot of folks who use OpenShift maybe haven't seen the web terminal operator. That allows you to just bring up a command line, a web terminal, anywhere within OpenShift. Can be a huge time saver. It's just a very simple thing, but great to be able to navigate around OpenShift for those of you that prefer the command line. So the Operator Hub is available. It's fully supported on top of Azure Red Hat OpenShift. And again, products that are layered with Red Hat like ACM and ACS also are fully supported on top of ARO as well. Now we've come away a little bit from the Azure architecture, so let's go back into that in a bit more detail. And actually for that, what I'm going to do is I'm going to switch very quickly back to a slide. It's easier and quicker to show you via a slide what this looks like. Zoom in here quickly, and I'm going to get rid of the film strip. There you go. Actually, I want to do that as well. That's what I want to do. I'm going to show you the architecture. All right. So what's interesting is this is the same architecture for running OpenShift on Azure yourself, doing a self-managed architecture, as well as the managed service. So we follow the same architecture in both cases. And the reason for that is, again, we want OpenShift to look and feel the same no matter what cloud provider you're running it in, or no matter which way you're consuming it, from a cloud service or self-managed. There's only one small difference here, and I'll point that out in just a second, which is these infrastructure nodes. But let's start from the bottom and work our way up, talking about the architecture of Azure Red Hat OpenShift. So we start off with the control plane nodes, which used to be called the master nodes. Right? Master nodes, control plane nodes, same thing. Now we deploy 3 by default, and it's always 3. No more, no less with the managed service. The way it works is we're making use under the scenes, under the covers of Azure availability zones. But for those of you maybe less familiar with availability zones, or maybe who are a bit more used to Amazon or something like that, quickly explain, So a region in Azure is like West Europe. Okay, so that's a physical location, I believe based in Amsterdam. And within a region, you'll have availability zones like West Europe 1, West Europe 2, West Europe 3. Those are physically separate data centers. I think Microsoft calls them autonomous data centers. So they've got their own separate power, their own cooling, their own networking, their own storage, etc. And what we do with the OpenShift deployment is we deploy one control plane node into each of those availability zones. Now, what that means for you from a business perspective is far less risk of the cluster failing, far less risk of it falling over because it's fully highly available, right? So fully highly available deployment. If you have to take out the OpenShift control plane, you'd have to knock out more than one physical data centers within Azure. And actually, the funny thing is that happens from time to time. Very rare, generally, the whole region, whole availability zone goes offline. But if it does, again, we're running two other nodes in other availability zones that will just work with each other until the other node is back online. Again, what we're designing for with this service is full high availability for all the components from the start. There's less time debugging platform availability, less cost of your engineers looking at, are my nodes working properly? Is my cluster working properly? And actually more time spent on your applications, more time spent on what's going to deliver you business value. So high availability for the master nodes. Infrastructure nodes are a concept that we had from OpenShift 3 that didn't carry over to the Azure architecture with the managed service. Infrastructure nodes are for hosting things like some of the OpenShift infrastructure. So sometimes if you deploy OpenShift container storage or OpenShift Data Foundation, sorry, that's the new name for it, Ceph. If you deploy Ceph on top of OpenShift, then that'll sometimes go on the infrastructure nodes. There's also the router, or let's say the ingress controllers nowadays. Those are sometimes deployed on the infrastructure nodes in other deployments. Now with Azure Red Hat OpenShift, we've actually got fairly large master nodes. What we've got is actually quite a lot of capacity there available for running those components. So much of the things that would run on the infrastructure nodes typically just run on a master node or on an application node with Azure Red Hat OpenShift. So we don't deploy infrastructure nodes by default. You can do if you need to, but most of the time not necessary with the cloud service. And lastly, we've got the application nodes. That is obviously where your applications run. You start off with 3 by default, and again, if you don't change anything or customize it, you'll get a D-series virtual machine in Azure, which means a general purpose machine. By default, it's 4 cores running in your OpenShift environment. Of course, you can scale them, and what I'll do in a minute is demo how that is achieved, how we scale the environment. But just so we move on now and summarize that little section, 3 master nodes, 0 infrastructure nodes in most cases, and 3 worker nodes is what you get when you deploy Azure Red Hat OpenShift. Now you can see that they're all within one virtual network, the one VNet in Azure. What's not shown very well on this slide is actually they're deployed into 2 subnets. So a subnet for the master nodes, and a subnet for the worker node. The master nodes is always, control plane nodes is always 3 nodes. The worker nodes is anything from 3 up to 62 is the number of worker nodes we support at the moment. Bit of a weird number, but 62 worker nodes. And we're looking at getting that increased if it hasn't already been done fairly shortly. On top of all of that, so on top of the virtual network, we've also got an OpenShift software-defined network. For what it's worth, the actual technology is OVN, but again, this is kind of an implementation detail, and you shouldn't really care too much about the networking running there. The important thing is that from the Azure side of things, they're running on top of Azure networks. You can still do VNet peering, still use ExpressRoute, still use firewall, Azure Firewall, and all that kind of stuff as well. Working our way up the diagram, there are 2 ingress points by default into the cluster. So there's traffic coming in on the master load balancer or the control plane load balancer. And that's going towards these control plane nodes down here. That's hosting the API. That's what your command line will work with. If you're running scripts or tools against the cluster, then they'll talk to the master load balancer. By default, there's 1 ingress controller deployed and router. That's for hosting application traffic as well. So you can have all your application traffic coming down to this load balancer. If you like, you can also deploy additional load balancers, often really not needed, but if you need to, you can deploy additional load balancers if you want to load balance across, or normally if you want to have a ingress traffic sharding, but that's probably a bit more detail than we need to go to today. This is an old version of the slide, which I've updated a few times, but I haven't updated in this deck, so my mistake. But what you've got here is public IP addresses. What it should say is you've got the option to use public IP addresses, but what most customers do is deploy private clusters. I would say 90% of customers deploy private clusters. What that means is that these load balancers are not accessible from the public IP address. So it means that there's no public IP for getting traffic into the cluster. For my demo, that's what I did today. But for a real cluster, for customers' applications, you don't really want to use public internet. So often customers will get to the cluster via express route or via VPN or something like that. There's also the admin console running on top, so that's what I've been showing you, and that's what we're going to go back to in just a second. And then lastly, you've got the Azure Active Directory if you'd like to use that for login. What I'll do is I'll just reset this slide a second and just finish off this before we go to the next one. So this is again exactly the same architecture. There we go. So exactly the same architecture if you're running your own OpenShift cluster as with the service with ARO. If we look at the responsibilities on the left-hand side, though, when you run this yourself, you've got to build up all this infrastructure, have it all installed, have this all created, and manage all that part yourself. With the cloud service, the architecture is the same, but Red Hat and Microsoft extend our support all the way through to cluster creation, cluster management, monitoring, logging, network configuration, security updates, as well as platform support as well. So we take a lot of that burden away from you, and now, while it's interesting to know what the architecture is, you don't have to worry about any of the details. Let's come back over to OpenShift then, and what I will show you is how we scale those machines. We talk about the master nodes and the application nodes. So remember the master nodes, if I just jump down here, master nodes we've got 3, okay? So master 0, master 1, master 2, right? It's always 3, no more, no less. What you can do is you can have larger masters, but by default, they are 32 gig of RAM, they're 8 cores. So again, they're pretty beefy machines. And again, you can get a few of the other application or a few of the other infrastructure workloads running on those machines. The worker nodes, again, you're here with a randomly generated name. It says East-US 1, East-US 2, East-US 3. Again, they're also balanced across those 3 availability zones. By default, 16 gig of RAM and 4 cores, so a D4 V3 machine. Now, what we'll do is we'll come away from that view to a more simplified view, and that's called machine sets. Now, machine sets is a way of grouping up application nodes, all right? And you can see here we've got a machine set defined for each of the worker nodes with application nodes, East-US 1, East-US 2, 3. As I've just shown you, there is one machine in each of those machine sets. So if you're already familiar with some of the other Kubernetes services, sometimes this is called node pools, or sometimes it's called a set of machines or something like that. But this is a way of grouping up worker nodes. Question I get all the time. Great, 3 is fine to start off with, but how do we scale this deployment? How do we add more capacity to our cluster? So remember that everything with OpenShift is as automated as possible. But if you want to do this manually, you can say I want to edit the machine count, change from 1 to 2, and that's all I need to do. Behind the scenes, Azure Red Hat OpenShift will go ahead and deploy a new Azure virtual machine. It's going to install CoreOS. It's going to set up the containers for running OpenShift. It's going to assign the certificates. It's going to set up all the configuration. And what we're going to get in about 3 or 4 minutes is a worker that's online and available and running within my cluster. There's nothing else you need to do as an administrator. Again, if I compare this to running your own Kubernetes service, That's a lot of time spent building gold images, patching machines, running maybe Terraform templates to deploy that worker node. And even if you do this on one of the Kubernetes services, where maybe this is a bit easier, you've still got to consider then how all the underlying infrastructure scales as well. So does your logging scale and start monitoring that new machine? Does the metrics collection work on that? Am I going to be able to balance containers to that new machine as well? With OpenShift, all that is managed and automated for you. Now, while I've been talking, again, that should be in provisioning. If I go back to my machines now, see that this has started to be provisioned. Okay, so it's been registered in Azure. I've got another worker node come online, so I've now got 2 worker nodes in East2S 1. Right? If I keep on talking, in a couple of minutes, this will become available. What we'll try and do is jump back to this by the end of the demo, and you can. But for now, you have to take my word for it. And this machine should come online. And again, we shouldn't need to notice any difference, right? That was manual scaling. Now, what we can do is we can have machine autoscalers. I'm not going to set this up just now, but what we can do is when we do set this up, you can set a minimum number of machines, a maximum number of machines, so that it adjusts itself throughout the day, right? Maybe you've got a workload that needs more capacity in the morning, but less capacity in the evening. So OpenShift will manage that for you and add worker nodes and remove them as you need to. You can scale based on CPU, you can scale based on RAM, based on network throughput, and a whole bunch of other things. There's also the possibility to mix and match machine sets as well. So while these are all standard D4S v3 machines, let's say if you want to do an AI workload on Azure. If you want to do an AI workload, then you don't want to be using D-series machines because they've got no GPUs. What you want on Azure is NC series machines. They've got GPUs attached that's going to help you with AI kind of workloads, right? The way you do this is you can create a new machine set. Okay, and here's the template set up for you already. Obviously, this needs a bit of filling out to get this working. What we can do is you can also just copy a machine set from one that's already been created before. There you go. And much of this is done for you, but importantly, down here somewhere, you set the VM size, in this case for an AI type machine with GPUs, set to like a standard NC 4v3 or something like that. Okay. What that's going to allow you to do is have different types of worker nodes in the same cluster, the general purpose and AI machines. You can also add in F series, E series, and a couple of others as well. We'll get to that a bit later on. So we've covered the networking. We've just covered compute. Now, the other thing I just want to cover off and make sure we get time for that's specific to Azure is how the storage works with Azure Red Hat OpenShift. So those of you familiar with deploying lots of applications on top of OpenShift, you very quickly realize that you need persistent volumes. Okay? Or perhaps more specifically, you get persistent volume claims, which is an application saying, I need some storage. When you provision a persistent volume claim, most of the time it's associated with a storage class that provisions a persistent volume. What you really need here is to understand what type of storage classes are available for Azure Red Hat OpenShift. So those persistent volumes can be provisioned by Azure Disk. That's a fully supported native provisioner and built into Azure Red Hat OpenShift. Now we're just at a transition point at the moment with the way storage works with Kubernetes. There are 2 drivers available. So one of them is called an in-tree driver. That means the driver for provisioning storage is built into Kubernetes. There's also the more modern driver that uses the container storage interface. Okay. By default, we're using the traditional one, I think, for application compatibility or a few things like that. But of course, you could set this to be the default, or you could manually specify this whenever you create a persistent volume claim. And what you'll get is an Azure Disk provisioned for your application. Okay. So this answers the question, so how do I have application persistent storage with applications running on OpenShift? Using Azure Disk means you can use all the same security controls you normally would have. So you can have Azure Site Reliability Manager, you can use backups for backing up those Azure disks. And you can also apply any security policies you need to for the storage run by your applications. Other types of storage are available. Okay, so if we go down to our list, you can see that we've got built-in support for all the other cloud providers, but one that comes up a lot on Azure is Azure File. So we don't have a storage provisioner by default for Azure File, because when you deploy ARO, we don't need you to have an Azure File account set up. But it's very simple. If you have an Azure File or you want to use Azure File with your storage, fully supported, just give it a name, description, set the location and the storage account name, that kind of stuff. Takes a couple of minutes or so. And what happens is you get another storage class down here for Azure File as well. Right? I would say that most customers use Azure File and Azure Disk for their persistent storage. Again, there's a lot of other provisions available. So any one of these, again, are also supported with Azure at Home. So let's just quickly recap. So we've covered the deployment inside the Azure console. We have covered the patching and how that works down here in cluster settings. Covered that. We looked at the cluster operators and talked about how they are fully supported as part of the managed service with Azure at OpenShift. We had a quick look at the architecture down here. We looked at machines, looked at networks, we looked at storage. So again, those are all the things that are different with the Azure service. What again I haven't covered today is I haven't really covered deploying applications, because that's the same on OpenShift as you would do with any other environment. So if it was OpenShift running on premises or running in another cloud provider, when it comes to the developer perspective, deploying applications, that is always the same. That's by design. We don't want that to be different. The only real differences with the managed service, with the cloud service, is how the compute, storage, and network is set up on Azure. Then also how we support that service, the SLA behind it, which I've not mentioned. That's 99.95% SLA. So what is providing you again is a fully supported managed service for running OpenShift. It should be the simplest, easiest, cheapest, quickest way to get OpenShift running on Azure. Now, with that being said, I know I'm pretty limited on time. I've only got about 11 minutes left. I want to make sure there's some time for Q&A. But one thing I just want to show you is just the power of OpenShift brings you when it comes to dealing with complex applications. I'm going to show you a very quick demo on Service Mesh. So what I've got here is I've got a simple application deployed. Well, actually, it's perhaps not such a simple application because it's made up of a couple of different services. What the application is a simple bookstore. I think it's great that my demo bookstore has got a demo here called the Comedy of Errors. It's got a book called the Comedy of Errors. So maybe if my demo goes wrong, right at the end, that's because the demo gods running out of luck. Right? But it's a bookstore. It's a very simple web page where you can see it's got the book. It's got some book details that come from the details service. I'm going to zoom in a little bit. It's got book reviews and a few other bits to the page as well. Now this service is actually set up, or the application is set up, that every time I refresh the page, I'm getting a different version of the review service. So I'm hitting F5 and refreshing the page. See, there's a version without any stars, there's a version with red stars, and a version with black stars. Okay, and it's totally random each time I go there. So kind of that's by design at the moment, just to show you there's lots of different services running behind this. And if we come back to OpenShift, you can see that this is made up of 6 different deployments. There's a container running the product page, container running the details page, container running reviews, version 1, version 2, and version 3. There's also a container running the rating service as well, so the book rating, which we're not going to use so much today. What I want to show you here is that when we've got an application that's made up of several containers, when we come to managing this using just command line and just empty Kubernetes environments, it becomes quite complex to see how these services work together, how they interact, how does the traffic flow between these services. One thing that's very cool is this application is enabled with Service Mesh, and that is a built-in capability within OpenShift. What OpenShift can see is actually that these services are talking to each other, and this is enabled by a tool called Kiali, again built into OpenShift. Now we had to enable this application to use service mesh, but what that means is that every request that's going to one of these containers is passing through what's called a sidecar container, right? So if we look at this, pod, okay, so pod is a collection of containers. You can see there is a container running for the product page and a container running called Istio proxy. That's the service mesh, right? Intercepting all inbound and outbound traffic throughout those containers. What that's allowing us to do is when we come to this complex deployment is to be able to build these graphs of traffic working between the services. This is all done in real time. So you've noticed now that my graph is kind of looks like it stopped working, right? There's no traffic going to the service. So if I do something in the background, if I actually run a DDoS attack, or if I just run like a bunch of requests, let's say, in the background on one of my monitors, what you'll see in a second is a bunch of traffic hitting these services. It's not going to happen instantly. The reason it's not going to happen instantly, you can see it coming in now, is because we're running a 1 minute rolling average. And so over an average of a minute, we didn't have any traffic visiting the service, right? But now you can see that I'm running tons of requests, right? So I'm hitting the page many times a second. And what that's doing is, again, this product page is set up to randomly send traffic to one of these review services, version 1, version 2, version 3. Remember, version 1, no stars, version 2, black stars, version 3, red stars, right? I can also see the details service and the rating service in behind this. Now, if we go kill one of those applications, if we go kill one of them, so if we go, let's say, to review service, and we go simulate a failure and undeploy it. Okay, so what it's going to do is going to get rid of that application, get rid of that container. There you go, it's now drained, it's no longer available. We switch back to this view. Again, nothing's going to change right now because we're running a 1 minute rolling average, and over a minute, on average, the requests are working pretty well. But in any second, if I don't touch anything and all is going well, you're going to see a big red line pop up. Okay. Obviously, it only refreshes about every 15 seconds. And what's going to happen is it should be able to show us that failure in one of those applications. It's going to show us the container stop working and show us the failure. Anytime now. Again, they're always embarrassing if the demo doesn't work at the last minute. I think we can see it starting to happen, right? If you look at the average, there's far less traffic going to the version 3 service, the one we just killed. Version 2 and version 1 seem to be working okay. There we go. Now you see we've got no traffic going to that service at all, right? Nothing whatsoever. Actually, all I did is I scaled it down, actually, so I didn't crash the container. That's why we don't see a red line, sorry. But what we can see is that, hey, if I'm an administrator looking after the complex microservices application, I've now got observability and visibility into why my applications may not be working, may not be performing correctly. Now, Istio allows you to do many things here that are far cooler than just this simple demo. You can inject your own individual errors, and we can see what kind of traffic is running. So here it's HTTP traffic, but we can also see gRPC traffic. We can see REST calls and that kind of stuff. We can see again if you're having intermittent failures in between these services, maybe like one request in 10 is not working. That will show you up in Kiali, show you up in the service mesh. So what I'm showing you is just maybe one little part of one of the tools in OpenShift that makes running applications on OpenShift far more suitable for production, far less time spent for you as an engineer looking after and running a container environment, right? To providing all the tools and technologies you need to run applications at scale in production. Okay, with that being said, that's the last of my demo. I'd love to keep on talking and show you more capabilities of the platform, but it's amazing how quickly an hour goes. And I want to make sure we've got time for questions as well. So what I'll just say is, again, if you want to learn more, you can go and search for Azure at OpenShift. In fact, if I quickly show you docs.microsoft.com/Azure OpenShift, there is a lot of documentation here about the service. You talk about how this all works, and you can dig into this tutorials, how to create clusters, quick start guides. There's also things like, quickly show you here, the support policy for the service, so a list of do's and don'ts and how we run the service. There's a list of machine types we support, control plane nodes and worker nodes. There's also information here about the life cycle. Again, I've tried to show you some of this quickly during a demo, but if you want the more detailed version, then you'll find that there. Lastly, I'm afraid I just need to do a quick plug for a book. So Getting Started on Azure and OpenShift. There we go. I wrote a book on Azure at OpenShift, so you can go grab that there. Maybe I'll drop the link in the chat in just a second. But if you prefer reading at a slower pace, and maybe if you can't keep up with my accent or I'm talking too quickly, and if you prefer reading, then there's a version that covers a lot of what I cover today, and of course a lot more as well. With that being said, I will stop talking and stop sharing and ask if there's any questions.
James, thanks so much. This is very informative. Learned a lot today, and I really appreciate you spending the time with us. I just want to let the people know, as always, we've recorded this session and it will be available 24 hours after this recording on the site where you've linked, where you registered for the event. I'm going to stop the recording now and we can just quickly handle one or two questions.